Okay, my friends, I am kind of excited, and I'm going to try to make this as simple as I possibly can. I've been talking about probiotics and how they can make you healthy and how important they are in your everyday life. Now, people that have been affected by antibiotics have destroyed some of these strains of life that live within you and know how to fix you. If you destroy them, you cannot be fixed in some circumstances. When you become invaded by something, they call on that bacteria that is no longer in you, the probiotic that was living in you, in your membranes, and it's gone because it was killed by antibiotics, and then you need the product that it produces. You can't produce it, so you become invaded. Now, the only way it appears to get completely reversed is phage therapy. I'm going to explain to you the difference between phages and bacteria and viruses and enzymes and catalysts and all of the different things, and how they get into your body and how you can eliminate them. And I think it's pretty clear now that this is a process that can be done. And I don't think it's all that difficult, but it's going to require some serious investigation. Okay, my friends, this is like deja vu all over again. And why do I say that? Well, I got up this morning, and I always get these science alerts. This is from today. It just came out 21st January 2022. Special phage therapy clears a patient's resistance infection after 798 days. Well, why is this like deja vu? Well, let me explain to you in a second. This person had 700 days of antibiotic treatment. The infection of a 30-year-old bombing attack victim was still raging. Once you get cut and infected, and if you don't have something to fight back, you are going to be attacked like hell, and that's what happened to her. Now, so nothing happened for, that's like 2 years or so. Now, confronted with little progress, clinicians decided to turn to a combination of antibiotics and specialized bacteriophage therapy. What's that? It's probiotics. A new treatment that harnesses specialized viruses that infect and kill bacteria. That's what probiotics do. Well, we'll talk about that later. Her unique and successful case has now been described in Nature Communications. Let me explain to you why this is deja vu all over again. Okay, this is really a strange and, circuitous route to finding out about probiotics. I discovered mud fossils. I was posting all over the place. I was real upset with academia because they wouldn't listen. They claimed this was a carved head, and the nose is splayed, the cartilage is here, the blood is the FeO2 and FeO3 blood coming out of here, the black blood, the red blood. I mean, it's no question, it was real, and I was being assaulted. So this guy contacts me, says, we're going to do a documentary about your discovery. I said, oh, fabulous. So he comes up, and they did a regular documentary sort of thing. And I showed him all the stuff. And in the meantime, as we were doing this, filming it, he related a story to me where he almost died from Lyme disease. And of course, I get intrigued by anything that's like, because I said, well, how did you get out of that? He said, they sent me home, told me I was going to die, get my my affairs in order. I said, whoa, that's not good. I said, so how did you get out of it? He says, I took probiotics. He said, a week later, I was out jogging. I said, you're kidding me. He says, yeah, it was like 2 years ago. And I'm perfect. I never had another problem since. And I said, they told you couldn't be cured. And you took probiotics and you were cured. He says, yep. I said, God, come on. So, of course, that set me off on this path. And so I started to look back, and sure enough, in 2011, the National Institute of Health says, oh yeah, probiotics, that's the way to get healthy. I said, oh, this is amazing. So I started going deeper and deeper and deeper, and then I started to learn every detail about it. CD cell differentiations and how the macrophages work and apoptosis and all of the situations that happen within your body, the chemistry that happens. Because that's my background is chemistry. Well, I got a lot of different things going on in my background, but chemistry is one of my biggies. All right, basically everything there is chemical interactions and bonding and how things attach and how water moves through, I mean, this is all chemistry and about how forces interact with each other and, the whole thing. And like I say, I was into this pretty serious. So this is not something that I just made up yesterday. And I understood pretty well that, how basically everything works. Well, I did, actually, because I came up with electron flood theory, where Bohr theory is just nonsense. Rutherford, Bohr, all of them. Einstein, totally wrong. Light can accelerate, light can slow down, light's a particle, it has a magnetic field surrounding it. As it comes through, it makes a big wave for the field, the particle comes behind it, that's the particle-wave duality. I show all these things, and I realized that nobody cared about reality. And when I brought forth the probiotic stuff, same thing happened. And that was 6, 7 years ago, once I realized, yeah, this guy was right. He was 100% right. This stuff cures you like unbelievable. And now they're finally jumping on board. And now I'm going to try to explain to you exactly what I have discovered. And I don't know if they have discovered this yet, but it looks like they're homing in on it. Okay, this is something that we need to look into. Is in this particular case, the patient's drug-resistant infection was due to a resistant pneumonia. A particularly nasty superbug forms persistent biofilms. That's cellular adhesion across a certain type of membrane. It's called a biofilm. It enables it to bounce back from repeated antibiotic treatments. So no matter how many times they give them the antibiotics, they're still going to get sick because they have that biofilm persisting, that membrane-bound biofilm. That new stuff has taken over your membrane, which is supposed to be your good bacteria is there. So you're never going to get healthy. And the same thing that's happening to the COVID people. These long haulers, that's the problem. Their membranes are still permeable. They're still being invaded. Now, the biofilms are structures elaborated by bacterial communities. They live in the membrane. They're bound in there, attached to the surface of different types of tissue fragments. Within biofilms persist cells from a subpopulation of metabolically dormant cells that play a major role in the capacity of biofilms to survive and recover from antibiotic treatments. You have to get rid of these biofilms. And I don't know if they understand, they're not just a film that's laying there for some reason. They are still saturated with these bacteria. They have to start looking at what exists in these biofilms. And I don't know if they are or not. They should be. I would assume they are, but I don't see, it's hard to follow what their real research is. And it's so slow and so localized to a certain group, and they don't share information. I share everything. I want everybody to know everything, and I want to know everything from everybody. And that's, in a capitalistic society, that's not the way it works. The more you can hide your information, the more capital you're going to put in your pocket. I don't care about capital in my pocket. I care about the information. So currently there's still a lack of data. This is not doing this stuff, because if they can't make a ton of money on it and hide it from everybody else, and bugs, I don't think you can, I'm not sure you can patent certain bugs. I don't know. Anyway, overall effectiveness of phage therapy for resistant bacterial infections. So there's no data right now, as well as the potential of any adverse effects may come to patients. So they really kind of sort of on the edge here. Because of this, not having this data and really not knowing anything about it because they haven't looked into it, doctors take precautionary steps, applying the phage locally to the infected areas. That's what they should do anyway. That's fine, rather than intravenously. And that's what they do. They give them all kinds of stuff and it'll kill it all through your body. And they think, and they may be right, but they think that certain cells travel from certain areas, like to your breast cancer. So if you have cancer in one breast, they take the other breast off because they figure it's going to move to that breast. My feeling is, because this breast was not protected by the correct bacteria, which is your probacteria, it's not probably going to be protected in the other one either. So yes, it will be infected. But the same thing with your lymph nodes. Your lymph nodes, one area has missing lymph, the stuff that breaks down all of the goop that is collected in because that's your dump, your lymph nodes. If you don't have the bacteria there to dump it, It collects and it infects you. Now, are you going to have them all through your whole body? You could, if it was the same bacteria that lived in that one was dead in all the rest of them. Yes, every one of them is going to be infected. You got to put back the bacteria, and now we have to do the mapping, and then we have to understand the cell differentiation, all the different CD factors, which are cell adhesion factors, which that's what allows cells to communicate. The bacteria is literally, these are intelligent little buggers. They're chemists, they're communicators, they're programmers. They're literally, our life is wrapped up in bacteria. And if your bacteria isn't good, your life will not be good. Look at this, because they were scared to do it. They just put it right into one spot, and they only did it for 6 days because they were scared of what would happen. However, 3 months after this new phase treatment, this bacteria, the patient's condition dramatically improved with bacterial infection finally beaten and cured. All right, this is the current thinking about phagocytosis, the current understanding of a universal biological process, which is the elimination of the waste in your body and dealing with chemicals in your body, ingesting and eliminating particles. Now, we're talking about microorganisms, foreign substances, apoptotic cells, which are dead, cells that are being killed by your own, they die, cells that die. Phagocytosis is found in many types of cells, and it is in consequence an essential process for tissue homeostasis, which means keeping it on an even keel. Okay, once again, I don't think this is correct. And they don't know this, I don't think. If somebody can prove this to me, I'd love to have them prove it. They say that bacteria are much larger than viruses. Yes, they are, because they are the big single cell that creates literally viruses and enzymes. Virus and enzyme, identical, same thing. No difference whatsoever. They're catalysts, they're molecular breakdown facilitators. All right, so the bacteria are much larger than the viruses that they end up creating. They are too large to be taken up by receptor-mediated endocytosis. Instead, they enter host cells through phagocytosis, which I just talked about, is that basically eating them. Phagocytosis of bacteria is a normal function of macrophages. Those are eaters of dead things. They patrol the tissue of the body and ingest and destroy unwanted microbes. They think that's what happens, is they're entering in through this patrolling and ingesting of these particles that are in your body that should have been killed. Well, I say yes and no. Those particles should have some way of being broken down by the bacteria that was in these phagocytes, in your lymph nodes, and in these places where they have to have that chemistry to interact with the attacking chemistry. The attacking chemistry has a molecular signature. It will have like a whole bunch of different codes on it. That your bacteria in your body can read those codes and say, hey, that guy doesn't belong here. We got to get him out of here. He's going to start taking over our stuff, and then we're going to be in trouble. And if he does, you're in trouble. Now, how does it stop it? The first thing it does is say, hey, I see something coming down through the bloodstream. The tonsils told me. The thymus told me. These are areas that pick up signals. The tonsils are very, very important. I had mine out. And your tonsils pick up food that goes by them and say, hey, whoa, there's some problems coming down here. Get ready. Send out the lactobacillus guys, or whatever it is. And they just think they cut them out and throw them away. Same thing with appendix. They took that and cut it out and threw it away too. That's where your bacteria lives in case your intestines get destroyed. And then it pulls them back out of that little pocket that's called the appendix. Boy, I'll tell you, when you get old, your mind slips. Anyway, this is the problem. They're not coming through that. They're coming through there, possibly, yes. Because you can't ingest them. Your body can't break them down. All right, so this is what I want to see them look into, is these CD maps. CD means cellular differentiation, like they're globs and clusters of cells that can be changed due to surface expression. All right? So something on the surface changes. Now, how does it change? You got to break through those membranes. That's the key. The membranes protect you from everything. This is what happens is you're breaking through them. There's like I think it's like a sugar layer around it that these phages attach to, and they have to find the correct molecules. They grab on, and then they literally are an injector. They're literally an injector. If you look at it right here, you see this? This thing here they want to kill. They find chemistry on here that likes these legs and says, ooh, that's the guy we're looking for. Now, it's got a bunch of goop in here that is the deadly stuff. This is the killer stuff. And right down here it goes, and it shoots. I'm serious. It's just like you coming up and shooting it with an ejector. And they find the ones, if they can find the chemistry that likes these little legs, boom, they attach. They understand. I mean, these are programmers. These are little robots sent out to kill invading bacteria. There has to be some kind of major intelligence, cooperation, interaction, communal networking that is just elegant. Now, obviously, the invader does not want to be killed. So it will do everything it can do to try to hide or get in places that these things can't get to. So there's a lot of nuances here. But there's also a lot of obviousness that has been just skipped over. And again, this guy, or this lady that was really damaged severely and infected, just like my buddy was. You know, we became buddies after he was going to do the film on it, the documentary. And I've stuck up with him and followed him, you know, kept up with him for the last 6, 7 years, and he's still doing perfect. So, and this has helped hundreds and hundreds and hundreds of people. And I am working with Marguerite O'Reilly over in Ireland, and she's literally cured her son of autism in the most severe end of the autism spectrum, and he's back down to being virtually normal. And that only took between 1 and 3 months to basically completely turn him around. And this is all being, still was poo-pooed at this time. This was three years ago or so. We really got in with John Jr. and figured out what was wrong with him. And you can almost always relate it to the digestive system, the poop and the urine and so forth. And when she went and told the doctor, she says, oh, he's got terrible poop, terrible urine and all this. Oh, that's normal for autistic kids. Well, yes, because that's the problem. This is the problem. Any disease you have, any single disease, I don't care what it is, eczema, acne, depression, put it in and say, followed by gastrointestinal disorders. And they say, yeah, if you have that disease, it will cause your guts to do such and such a thing. No, your guts cause the disease. All right. I am a material scientist. Everything. I don't care what it is. Light, energy, the whole 9 yards. Heat. All right. Atomic stuff. And I have the new atomic flood theory that it's the dipole nature of particles. That's a whole nother issue. But I am fully qualified to talk in this realm. And I understand how molecules work and how they adhere and all of it, because everything is nothing more than atomic. Everything's atomic structure. I don't care what it is. I don't care if it's alive or dead. It's still going to be molecules. Now, they're talking about bacteriophages, which are where the bacteria that we want to get in our body, the good bacteria, can be injected by these little phages. The enemies of bad bacteria are our friends. They're both the same thing. And then it goes into all this. I'm going to leave it at this, but I think I can make a pretty good case. Well, they are now. They're understanding this now. But boy, I'll tell you, it takes forever. I went back to, even right now, if you put in National Institute of Health and COVID-19, you're going to find, and COVID-19 probiotics. Put that in. Just put it, well, I'll do it right now for you. You see this? This is probiotics in the prevention and treatment of COVID-19. This just came out in 2021. You have not heard, and I have not heard one single word of probiotics, about probiotics from mainstream. And it says saving lives and flattening the curve, the foremost priorities. Well, yes, it is, and they say the probiotics will do that. I'm going to come all the way down to the conclusion. I've read through everything, and you can yourself. Evidence supports probiotics' role in regulating the immune system, suggesting a definitive, which means, look up that word, it means absolutely certain role for probiotics in viral infections. And then it comes down here, it can reduce, probiotics induce suppression of the inflammatory cytokine response, may prevent both the severity and occurrence of acute respiratory distress syndrome. That's why everybody's dying from, making probiotics very attractive. All right, then it comes to, therefore, supplementation of probiotics in high-risk and severely ill patients, frontline health workers, might limit the infection and flatten the curve. However, there are no random controlled trials. This is my problem. And this same article, if you go back to 2011, 10 years before this, is virtually the same article, probiotics and the prevention and treatment of the help that it does to your immune system. They knew this. They did. The travel of medical information through the medical industry is glacial. Now, why is it so slow? Everybody's afraid of getting sued. If a doctor says to you, oh, you know what, you should probably try taking some probiotics, and then the guy doesn't recover, boop, sued. He might say, do this other stuff, and take the probiotics. This doesn't matter. They say, oh, the probiotics killed me. And he'll get a settlement. This is the problem with the medical industry. And I don't know how to solve that, because everything became so litigious. Everything is all, legal. So they can't say anything. That's why you don't hear anything about probiotics, because they want you only to take the vaccine. I'm not against the vaccine at all, but I don't care if you take the vaccine or not. If you don't have the probiotics, you're going to get long haul or continue to be sick. You're going to get it again. Just like that other thing says, you're going to have biofilms in there, you're never going to get better. Okay, I'm going to wrap this up right now. Phages versus bacteria. This is a very good, very short little portrayal of how these things interact. Now, before I do that, I want you to know we're looking for a coalition of people to get together that have all of these different capabilities, bacteria and facilities, and they can get a hold of me, but only if you're going to really be serious about doing this. We need somebody to do this. I can't do it, and I don't have any money to speak of to do this kind of stuff. So it's going to require money. It's going to require talent in a whole variety of areas. Bacteriologists, I do know some people in that range. And anyway, we need, if you really feel like you want to jump in on this, and if you have money, that would be nice. If you have some contacts in these areas, the medical field, because they don't listen to me because they think I'm a nutcase. So you're going to have to. This is my email. But if you really want to make a contribution, I just don't have time to talk to everybody about every little detail. But I want to put together a coalition where everybody can talk together in a big format. I can't do it one-on-one anymore. I'm overwhelmed. Now, here's this deal. This is from Life Science Animation. And they're talking about what are phages and what bacteria do and how they interact. It's very nicely done. Now, listen to it, and I'm going to probably interject. Here goes. Zurich University. Now, this is molecular mechanism of how these tail spike proteins in bacterial infections. Now,
bacterial diseases are becoming more and more challenging to treat, because many bacteria have developed resistance against antibiotics.
You know, the same thing is happening with this COVID variants. They try to protect themselves. If they say, ooh, we're not making out too good here, why don't we just change this little thing here? And it still does the same thing, only just a smidge different. And then your immune system has to recognize the new chemistry, gear up for it, and then adapt to it. That's called the adaptive immune system.
Innovative solutions for the treatment of bacterial infections are urgently needed. Phages, the natural enemies of bacteria, selectively infect.
All right, how do they selectively infect? How do they know that's not a good bacteria? Well, there's some kind of chemistry on this cellular layer that says, here's my address. It's basically like an address. And if you don't recognize that address as being somebody that lives within your community, then you attack and you get the damn thing the hell out of there. Now, these are attacking bacteria.
And kill harmful bacteria.
Boom.
Even if they are resistant to antibiotics.
All right, why is it because antibiotics, they're resistant to them? Well, the reason they are resistant is because they develop a new coating that is like putting new scales on. I don't know how to put it, like put new armor on. As they get attacked, they say, ooh, that spear went right through me. Why don't we put a little titanium on the outside? That type of thing. Same thing we do. Same thing everybody does. Same thing armies do.
However, to develop a safe and efficient treatment, we need to understand in detail how they do this. Researchers at the Zurich University of Applied Sciences are studying this process at the molecular level. They are looking at phages that consist of a head, a tail, and a base plate, where the so-called tail spike proteins are attached. The bacterial surface is covered by a complex sugar layer that are...
Oh, yeah, that's right. It is a sugar layer, and they say it's complex. Yes, it is. Sugars can form all kinds of different molecular variations, and apparently the sugar layer of bacteria is all different as far as I can determine. And they're trying to figure out if they can recognize layers that are not what you want to find, and then they can attach these killer cells, to these killer molecules to them, and have them attack the cells.
It allows for the binding of selected phages.
See, the binding.
Binding is facilitated by the tail spike proteins that degrade the sugar layer.
All right, remember I talked about the CD, cell differentiations. That's the binding part has to find the molecules that are ones that it doesn't like. And then it's going to inject it with all that nasty stuff.
So the phages can infect and kill the bacteria. The researchers will produce the tail spike proteins independently from the phage. Using dedicated laboratory equipment, they will study the binding of tail spike proteins to the bacterial sugar layer and monitor how efficiently it is degraded. The resulting data will help to better understand how to control harmful bacteria by phage treatments in medical and food applications.
All right, that's pretty straightforward. The bacteria tries to protect itself by changing its clothes. It changes the cell layers that are the outside, so you don't recognize it anymore. You say, well, that guy's supposed to have a black suit on. No, that guy's got a red one, forget him. Well, so now you have to say, ooh, if it's red and it has some other characteristic in there that it will recognize it and it will begin to be able to destroy it. But if you're so invadable and you have so many areas that can be invaded, you can't respond quick enough and that's when you get real sick and you die. And this new COVID is so aggressive, and anybody that has a pre-existing condition means that they have invadable tissues, and zip, it goes right in. Your case is in trouble. You may survive, but the more immunocompromised you are right now by having these bacterial layers, these films penetratable, you're in trouble. So we need to look deeper into this, and I want to get a coalition of things going on. I can't do this myself. This is not within my realm of capabilities. I can coordinate this. I can do some research, which I've done, and I think I've shown pretty precisely what we need to do. We need to map where these bacteria live. We need to be able to understand how to repopulate the interstitium. And don't forget, this is where the bacteria lives, in these fluid-filled spaces. This is called a membrane. and it's called, now they call it interstitium. It's 100% in your body. Every single surface is covered with this, and it separates that layer from this layer. And if this layer goes bad and you don't have the bacteria, it cannot stop the invaders. Now, they just discovered this layer in 2018. They knew that this existed, but they never really put it together how important it is. This is a transmembrane highway. All these fluid-filled bags allow the fluids to flow through your body, carrying bacteria and, all the things that you need for your life. But they didn't realize, and I'm not even sure they still do, how important the membrane-bound bacteria. It lives in these membranes. It doesn't just live in these bags of fluid. It lives in the membranes themselves, because there's so many. Well, actually, it does live in the fluid-filled bags. It doesn't live in this tissue to speak of. I'm sorry, that was a mistake on my part, because this is a membrane. All right, so it lives within the membrane, and within the membrane is in this fluid-filled bags. Unlikely it's really living within this matrix, but it could very well be, because there's so many layers of membrane. It's just hard to believe. There's thousands and thousands of them, where they thought there was only like one or two. So it's time to go this route and save some lives and a lot of misery. Because if you can cure autism within a few months, and you can bring people back basically from dead or ready to die, I think it's worth looking into a little deeper. And somebody should invest some money in this kind of stuff rather than, well, this money should be invested, that's fine. But if you see an avenue that shows some promise, I think that's where some serious thought should be put, and some serious efforts. That's just my point. And I will gladly help anyone that is working towards that end. Government, countries, I don't care. Because everybody's a human being, and everybody has the same vulnerabilities, and we're all getting sick.